Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Enhancing Energy Harvesting from PV Cells, Design and Evaluation of an MPPT Algorithm. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Friends, welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the algorithms that we have designed in the domain of PV cells energy harvesting or extracting the maximum power from the solar panels for the current technologies. So specifically for the electrical vehicles or many other domains. So let's see what we have designed. Before starting the video, let's talk about what we will cover into this video. In this video, we will initially talk about the application areas where the developed system can be implemented. Then we will talk about the model that we have designed, how to execute it, and what are the software requirements for that. Then we will talk about the current systems. Those are working in the same domain and what we have done in the proposed method. Finally, the experimental outcomes and findings will be discussed. So let's talk about the application areas. As I already told you that we are working on designing the MPPT controller for extracting the maximum power from the solar panels. So this is related to the solar energy harvesting to get the maximum power from the panels in order to charge the batteries or doing any other stuff. So specifically for the second domain, the main domain is for the electrical vehicles, which is very much demanding in the current systems. So other than that, the grid connected solar PV systems where the solar panels has been installed at the different areas, and using the sunlight they are generating the electricity which is further fed to the homes or utility grids and many other areas where the power can be extracted from the PV panels. Renewable energy management. So as solar energy is a renewable energy, so that is the domain where if you want to work with the renewable energy harvesting or the uses, this domain is also one of the area. So what exactly the MPPT is basically a solar charge controller which extract the maximum power from the solar panels in order to further fed the power to charge the batteries or doing any generating the electricity and that stuff. So there were certain algorithms those are working behind. This is not only the electronic circuit which is used to charge the further batteries. So there are certain algorithms at the back end. So one of the algorithm out of them is P and O method, which is basically perturb and observe method in the MPPT. This is basically the method. Let's talk about it, that because we have designed this one. So before going to this method, let's move that what we have designed, how to execute that code. So the folder that we are going to give you will be like this, in which there will be code folder and there is a model that we have designed in the MATLAB. So the MATLAB software we are using for it, this is a simulating model that is designed for the P and O method. So you must have the MATLAB software with you. The MATLAB version that we are using is 2019A. So you can use 2018 or 19. But for using the previous versions, you just still you need these versions to export them to the previous version. So in order to run the code, you just need to go to the folder where the model has been placed, and you just need to copy the path, Control C, and then go to the MATLAB and paste the path, Control V, and press enter. When you will press enter, you can see here the model has been seen and its extension is SLX. So when I double click on it, you can see the model that we get is like this, which is a MPPT model designed for the PV charging systems. So this is basically the panel having the input as a irradiance and temperature. So currently many of the systems has been proposed. There are number of MPPT methods there, but the PO method is one of the trending method, which is very much attaining so much interest from the researchers, and even further modifications are there. So we are developing the system which is basically representing the main controllers working for the generating a good voltage and the current in order to charge the batteries at the output. So here the irradiance and the temperature has been given to the panel, which shows that the sunlight and the light and the temperature which just lies on the solar panel. So the radiance that we have settled here is variable, it is not fixed, because the sunlight when move from one direction to another, there is a variation over the light for the solar panel. So you can change it accordingly, but we did change set the values this way. And the temperature we fixed is 25 degree. So further the solar panel, which is giving us the output from which we are extracting the V voltage and I current of the PV. So this is the direct voltage and the current that is extracted from the solar panel, which is further fed to the MPPT algorithm from which the maximum power has been extracted. So these two values are fed to this particular MPPT controller, to which a delta factor is also there. Accordingly, this algorithm is being implemented. This is exactly the code which is working for the MPPT using the PO. So when I double click on it, it will open the MATLAB code at the back end in the MATLAB itself, because this is embedded into the controller itself. This is the P and O method, in which the initial duty cycle, minimum duty, maximum duty is generated, and on that we have the algorithm that is there with the P and O method. You can get it online, where P and I is generated from the sensed VI. Further, there are certain condition in order to say get the maximum voltage and the current. So this basically works. The current drawn from the PV array is perturbed and given in a given direction, and if the power drawn from the PV array increase, it means if the output power is increases, the operating point get closer to the maximum power point, and thus the operating current should be further perturbed in the same direction. So it means in the same direction the operating point is to get closer for the maximum power point. That is the concept of the perturb. In generally, in order to understand this, you can follow many of the research articles. One of the example I have shown for you here, as per these condition, the maximum power has been extracted out. This is what has been designed into this. There were the multiple conditions using the delta and the duty cycles generated from the voltage and the new voltages has been decided. So from the model, coming back to the model, the MPPT's main task is to generate the duty cycle. This duty cycle is further used to generate the PWM. So this is the PWM generator. So the duty cycle that is generated as per the calculation of P and O method is fed to the PWM generator, due to which the PWM generates a sequence, and which is fed to this IGBT, or you can say the diode, through which the power is being extracted out. So further the power is being extracted out in the terms of I out and V out, which is the output voltage and output current. After working with this method, we have also analyzed the outcomes. So this is the scope where the PV's voltage, PV's current is there, and then what is the maximum voltage and the current we extracted out by applying the method has been shown into this scope. In the another scenario, we have calculated the efficiency, where the P idle power has been fed, and the power that we get from the PV is fed, and on the by the mathematical calculation we just calculated the average efficiency, which is drawn into this scope, where the P idle, P power, P means power from the PV, idle power, and the efficiency calculator has been shown. So in order to run this code, you just need to click on the run button. It will start executing. So you just, during the simulation, as you can see in the bottom side, the simulation is being processing. I'm rerunning it again, so you can see when I'm clicking on the scope during the simulation, it will show us the results. So you can see the simulation is being happening. So these are the scope values during the simulation. I'm also opening the another scope where the efficiency and the idle power comparison has been shown. So you can see this was the voltage that was extracted from the PV and the current, then how it is increasing the power by getting the maximum power. So initial power extracted from the PV was around 60, where through the MPPT P and O method we are getting up to 150, and same for the current purpose. And when we are talking about the efficiency of the system, you can see it is nearly one, dropping at certain points when might be the sunlight variation is there. So this is the curve where you can see, in order to show you, you can see here the red curve is there as well as the blue curve is over it. It means the power that we are extracting from the PV is nearly to the ideal one, and there is a very less variation among the both, and the system is more efficient. So this is what we have developed by using P and O method for the MPPT power extraction from the PV channels, and especially in the domain of the electrical battery charging. So further modifications are still possible into it. So this is the model that we have designed in the Simulink of the MATLAB. So the researchers and the real world experimenting and the industrial people can contact us directly to get the details further, and we can also get involved in the ongoing research in order to support them. So thanks for watching the video.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.